Hello, and welcome to the Hives series on PCB Design with KiCAD. My name is Ben, and in this series, as you may well be aware of, we've been walking through the PCB design process using KiCAD as our design software. In the last video, part 4E, we finished off the schematic capture with a look at the ERC, or the electrical rules check, and a few bits of schematic miscellany. In these next few videos, part 5A, B, and C, we're going to shift focus to the layout portion of the design process, in which KiCAD calls the PCB view, which will actually be physically aligning and orienting the actual components on the board and connecting them with traces. In this specific section, part 5A, I'll introduce the board editor and look at some of the setting up some of the board's defaults and design rules. So let's get started. If you're just opening up KiCAD for this video, go ahead and load the project via the File menu and then open up the PCB editor either by double-clicking on the layout file with the extension KiCAD PCB or by clicking on the PCB editor icon on the right. That one, which will open up the current project's board view by default. If you're coming from the previous video, you can or have the schematic editor up for whatever reason, you can always also click on the icon highlighted here to open up the PCB view. So this is what the layout view looks like, or the PCB view, if you prefer, PCB editor view. The units and grid, as always, are going to be on the left-hand side there. Underneath, there are a bunch of other display-related items, including the rat's nest, zone filling, and outline modes. On the right-hand side, we've got all of our routing and zone tools. Below those are drawing tools. And on the far right, we have layers and object selection and viewing panes. You might notice the title block in the middle of the design view again, in the layout view again. I personally hate the title block here. It's just frankly distracting, so I always hide it. You can hide that by going into the Objects pane on the right and clicking the little eye icon next to the drawing sheet. It's kind of towards the bottom a little bit. Next, you typically want to set the units and grid. Unlike the schematic, in which the grid is really important to KiCAD's functionality, the grid is very flexible in the layout editor and will often be changed frequently. I personally prefer that 50 mil grid to start. You can always change it later if needed. Select mil units on the left if you'd like, or keep it in millimeters, whichever. It's totally fine. This will define pretty much all the units for everything in this view, though, so do keep that in mind. And your grid spacing is shown up top there as well. All right, so next we're going to spend the rest of this video pretty much looking at setting up the board, the structure of the board, as well as some design rules and default settings. You always want to set this up first before you start doing any layout, because if you set it up last, you're going to be really sad when things don't fit anymore or don't match anymore, and you get a whole bunch of errors. No good. So you're going to open up the board setup window either by this icon here or through the File Board Setup menu. And it looks like this. It offers many settings to adjust your design. There's a similar window for the schematic that we didn't go through, but it's much more important to understand these settings than it is for the schematic view. The schematic is mostly like colors and stuff. It's not really that useful. The first selection here, this board editor layers, allows you to select the layers available to your design. You can select and deselect these as you see fit through your design. I believe they will be completely unused if they're deselected. Not just they're invisible, but they're actively not available to be used. This can be useful, for example, if you don't want to put copper or silkscreen on the backside of the board, for example. By removing them from the layers and layer options entirely, you minimize the chances of error, like accidentally putting something on those layers. You can also add user-defined layers here if you want or need, maybe for like custom assembly processes required for your fab house or some other specific information, but it's certainly not necessary for this board. The physical stack-up pane refers to the physical rather than digital layers of the board. This is where you would set your board to be 4 layers or 8 layers using the copper layers dropdown in the top left. You can do some really advanced setup in here, although I'm honestly not sure about how much of it is actually used in other parts of the software versus just being for your own knowledge. And the units in this pane, as I mentioned earlier, and all other panes are derived from those units specified a few slides ago in the main editor, layout editor. And the units look really wonky because I like mils, but KiCAD is by default a metric program. So everything is in metric and then converted, which is why it looks kind of wonky. Skipping down a couple, we get to some text and default graphic defaults. The defaults are normally okay, and you can of course always change all of this in line, like as you're doing stuff, and it can be hard to gauge what you need. A good rule of thumb for text or silkscreen in particular is that height and width will be about 6 times the thickness, roughly. It can be a really good exercise, both for you as a designer and also very useful, to make a dummy layout that only has text on it on the silkscreen layer at various height and width ratios for your reference, and then you can just print that board on like a piece of paper and keep it handy for scale, because you can print it one-to-one copy. The constraints pane is where all of our actual design rules are going to go. And these define exactly how small things like spacings or sizes can be in our board. These are defined by your chosen fabrication house where you're getting your board made, so read their instructions very carefully. Many fab houses have software-specific instructions these days as well, but if you mess this up, this can be a really easy way to make your design unfabricatable and require redoing the layout or or you get back a board that is completely out of spec and then damaging your parts or something like that. I'm not actually going to adjust any of these things here because I'm not getting it fabbed, but do not forget to set this. It's very easy to forget to set, and then they'll come back to you and be like, hey, your board doesn't fit into any of our spec, and you'll be like, that's confusing. If you set it after doing the layout, you can also do that. It's just be prepared for a bunch of DRC errors and potentially significant redesigns. So it's usually a good idea to pick your fab house first and then design to that rather than designing to something arbitrary and then picking a fab house and having to redo everything later. There's also an option to adjust violation severities, switch things from errors to warnings. Pretty much going to recommend never to change this unless you are very confident of what you're doing, because you might end up with a missed error if you're not careful. In predefined sizes, this is a big one. We can set some predefined sizes for traces and holes. This will make our lives a lot easier later by allowing for like hot swapping of sizes. So what we're going to do is use the plus button both under tracks and vias to add a couple of different specific options. We'll add these track widths and these via diameters and hole sizes. The parameter diameter for holes and vias refers to the diameter of the hole plus the annular ring. It's generally a good starting point to have the ring diameter, that is the diameter parameter here, be about twice the hole diameter. And larger diameters meaning larger annular rings, can make soldering a little bit easier. The default values that I've provided here are not required by anything. They're just defaults that I personally like. I like to keep my trace sizes, my minimums, above the minimum value if at all possible, which is generally around 6 mils, but it could be a little smaller depending on your the fab house. And this reduces the possibility of broken or damaged minimum width traces and traces that are more likely to see issues. For signals, I generally try to use 12 mils and then neck down, meaning shrink briefly if necessary, like between paths or something, to about 10 mils. Power traces should have the largest reasonable width possible. 25 mils I found is a pretty good balance, and according to a trace width calculator at Advanced Circuits, this can be used to pass 1 amp through external half-ounce copper with just a 10-degree rise in temperature. 16 mils is a really good necking size for brief lengths over which 25 mils can't fit, which is why I have 16 mils as my other option there. I could have probably chosen 20 or 22, but I don't know, I like 16. For vias, the 16 mil diameter hole for vias is actually a classic default. It's really good for small currents and signals, very traditional, and the diameter being 32 is just double that. That's a really standard kind of hole to diameter ratio. The 40 mil hole is about 1 millimeter, and that'll fit a standard pin header if you need a via but don't have access to electroplating, like for instance at the Hive. It's also good for a lot more current. Now, it's not typically necessary since you can use multiple small vias instead of one large via if you needed to pass a lot of current and didn't have a large via. Smaller vias can also be nice because they're so short, they can pass large amounts of current briefly without too much temperature rise, but it's a discussion for a completely other day. You can also group nets together into groups called net classes, which are exactly what they sound like. They're classes of nets to give them all kind of the same default settings. This can be really useful, for instance, if you want all of your power traces to be very wide or some signal trace to be very narrow or something like that. So let's go ahead and define a power net class, and we'll adjust the default net class as well here to the settings on the left. Clearance defines the clearance is the first one there. That defines the space between this net or any net on this net class and a copper on any other net class. Like a trace width, the minimum allowable setting increases the chance of a failed board, so it's always better to be a little bit larger than the absolute minimum if possible. For the Hives tool in particular, since we don't offer any protective solder mask layer, it's actually important that this clearance setting is set quite large, 30 or 50 mils probably, to reduce the chances of accidentally jumping traces or to a plane when soldering. Micro vias, which are the U via that you see kind of in the middle there, those are really super tiny vias that are typically used with BGA style components or high density ball grid style, high density pads. These will add a lot of cost to your board and are usually not necessary, especially at hobbyist level designs, unless you really can't find an alternative package. I suggest trying to avoid them. DP on the right stands for differential pairs, which are used when impedance matching is important, like for USB data or antennas. If you don't know what that is, don't worry about it. It's really not that important. It's not important in this design at all, and it's a more advanced technique. So we're going to assign, at the bottom, we'll make assignments to our net classes. So we'll assign the battery terminal, the positive power terminal to our net class, as well as ground. You can only do one assignment per line, and you can Alt-Tab into the schematic to double-check the names if you'd like. Wildcards, meaning with an asterisk or a question mark, can be used. They're totally valid, as well as regular expressions. But patterns are only going to match explicitly named nets. So if you just put an asterisk there, it'll only match named nets, not all the unnamed nets. And net class assignments are listed in priority order from the top down. The pattern matching is important and relevant here because that means that any unnamed net will be on the default net class. So that's why we adjusted the default net class specifically. You can also name net classes or assign nets to net classes in the schematic mode by right-clicking on a node or a net. Obviously, I didn't do that, but you could do it if you wanted to. Whenever you're done with this, you can go ahead and click OK. And that ends part 5A of our design tutorial series, in which we introduced the layout editor and a number of pre-layout board setup settings. As always, a PDF of this video is available, linked in the description, and hosted on the Hive's wiki. In the next video, part 5B, we'll actually go through the placement and routing steps. That's the meat of your layout process, so could take some time, but we will see you then.